The point of the elevator is if you have a really long extension and you want, let's say, an arm or an intake on the end, and it requires a motor, but you don't want the weight of the motor on the end of your elevator because it can make your robot tip. So you have, with this mechanism, you can get the weight of your intake motor on it makes your center of gravity closer to the ground, so you're less likely to hit because it's not at the end. And it also gives you your intake more power because it's not only powered by this motor, it's also powered by this motor.
So essentially the basic version of how it works is if you see there's a motor on either side, and when both motors are powered the same way, it extends out. And when they're powered the same way, the opposite direction, it retracts back in. Now on this end pulley, our belts are wrapped the opposite directions, if you guys can see that. So when they run opposite ways, they're able to spin. So this will spin. So that's what Akshay was referring to as the intake or arm on the end of the mechanism. And this is a ton of benefits for us because that makes our elevator, our linear slide, super fast, super strong, and we can have an axle on the end. So that's the basic explanation of how it works.
To add on to what Sophie said, both the extension and this axle are powered by both motors.
Yeah. Do you guys have any questions about it so far? Like how it works, what it is? Okay, cool. So the reason we designed this was we were thinking, if any of you guys are familiar with Upper Creek's robot from this past season, Freight Frenzy, we were thinking of designing a robot with a turret that would have something along these lines on it. This is a first prototype of the differential elevator. And it could potentially have an intake on the end of it. We would tilt down, put something up with this axle, and then that would allow us to extend and outtake the way that Upper Creek does. And so that was the concept basically for this. Do you want anything to add, actually? Yeah, sure, what's up?
How do you compensate for like the shift in the center of gravity for when you fully extend the arm?
So we haven't actually put this one on a robot, but I can talk about how we did it on our robot over there, Defiant. We just made our drivetrain, our center of gravity, really heavy. And also, if you're familiar with our robot, our intake arm, we added a ton of weight to that side. And we also added steel plates on the front and back to make sure that that couldn't tip at all. Because tipping is a huge issue, and if you tip, getting back up is something that's really important. And also, another thing about tipping is getting weight off of the end, which is a huge benefit of this one, especially if you want something like a motor at the end of your extension.
So it's as if we could have had a motor powered this arm, except the motor would have been here, and we would still been able to power the arm.
Yes.
So what kind of slides are these and what kind of pulleys?
So these are Masumi slides, 3 stages, 300 millimeter long, they're 3-stage slides. The pulleys, all of the idlers are 10-tooth size. They're from Amazon. These are 60-tooth, and these are 40s on the motors. They're 40s.
Okay, and also how did you rig it so that both of the motors are running the same system?
Okay, so I don't, can you repeat the question?
How did you rig it so that both motors are running the same system?
Okay, so both the pulleys are on the same axle. So if the belts are turning in opposite directions, what happens is if this pulley's spinning this way and this pulley's spinning this way, the axle is locked. So then it just turns into a normal belted slide where the belt is attached, like it's rigid. So then it can just extend like a normal belted or string elevator.
So essentially, it's the lock, like what we have, because if this had no lock, it would spin continuously and freely, right? You see, it's a continuous belt. It would just keep spinning, and that's what happens when it does this. It just continuously keeps spinning. And so because these are wrapped differently around the belt, when they're running in opposing directions, it locks it, which is why it's able to extend. And you see the pulleys don't move when it extends. Questions? Yeah, what's up?
How did you do the carousel on our robot?
Oh, okay. Here, would you retract this? Okay, so our carousel mechanism, so we used to have a little arm, a little like C-channel with a wheel over here, but that was really bad for, as you were pointing out, center of gravity. And so what we ended up implementing was right here. If you see our intake spins, it's powered by this motor in our channel, coaxially. And so we decided to actually just take that and we put a belt on the axle that was powering our intake, this axle, and we just turned it into a carousel mechanism. And that's our carousel mechanism for this robot.
This roller just contacts the carousel.
And it's just surgical tubing around a TPU print. Any other questions? Oh, about the robot or the differential?
Yes, name. So differentiation. So what is actually the mechanism to make it differentiation? Because usually we were expecting some like really compound like gears there, but I didn't see all of that. So.
Yeah, so the original design of this, the concept idea model here, was that both of these pulleys were going to be on different axles, and they'd be just a little bit offset, and there would be gears separating them in between, and that would be the lock, like we were talking about earlier. So that's the differential part, but we simplified that up into wrapping the belts the different way, actually just completes that in a lighter, more efficient, less slack because less gears way of doing it.
So rather than a spur gear differential or like a miter gear differential, the differential like is the belts and the pulleys.
Amazing. Thank you.
What kind of pulleys and slides did you use?
Like I said earlier, these are 60 tooth off Amazon. The ones on the motors are 40s, and these are all 10 tooth. And they're missing these
They're
legs.
GT2 belts
Yeah.
for, they're
For
commonly
3D
used on
printers.
3D printers.
The slides we used were Misumi slides, the 300 millimeter 3-stage.
Yeah.
What model you are using?
These are AndyMark 3.7s, right?
Yeah. We had these lying around, but I would recommend using the GoBuilder ones.
We just had spare motors and decided to put them on the prototype.
So you, go ahead.
You can go first.
You talked about it was originally going to be a differential like in a car when I used the word differential, but then you abandoned that to just these two belts. So is it, I mean, is there a what causes it to either go forward or to lock up? Where's the lockup piece?
So we didn't abandon the differential to replace it with two belts. It was gonna have two belts anyways. What we did is we simplified it into a more condensed version that got rid of the gears. You can point it
Okay,
out.
so as you can see, this shaft doesn't move as it extends. So what happens is it's the same as this belted slide on here, except it's just two belts powering it. Now, and then what happens when you spin, when both these pulleys spin the same direction rather than opposite directions, is it just becomes just a giant belt loop and it just spins.
One issue with this design is with the giant belt loop, there is nothing holding the elevator in place, but that can be tuned through programming and PID and encoders.
So maybe I can explain it as the speed difference between the motors and the direction difference between the motors determines how much power goes to the intake and how much power goes to extend or retract.
Okay, so if you had the same thing and we're going for a lift, gravity would be working against you in a big way.
Yes.
Okay.
Yes. But still, it's the difference in the motors that
Right.
tell us, it's the difference in the motors that tell us whether we're spinning axle full speed, extending full speed, retracting full speed, or doing some combination of them.
And so is there some sort of clutching mechanism that I'm not aware, that I don't see on it?
The clutching mechanism is, are the motors spinning, are the belts going in opposite directions?
So are the belts, are these, when I think of GT belts, I think of something with teeth, but are you rerunning the back of the belt so it's designed to slip?
No, it doesn't slip.
So
Okay.
the way we account for them, we have the belt reversed. So on this part and on the other, on the motor side. So if the motors do spin the same way, then what happens is the pulleys turn different ways. I'm not wrong. And then what happens when they turn the same way is then the belts, since they're going the same direction, but they're also locked. Wait.
Okay,
Yeah.
So I think another way to say it, because I think we've been saying the same thing over and over again, I think a different point of view on it is these two pulleys are locked onto this axle. These two pulleys, belt no belt, put two pulleys on this axle. The axle has to spin the same way. They cannot spin different ways because they're set screwed on. Does that make sense? That part, right? So when we try to spin them different ways, this part locks. This axle cannot spin. So that stops the belt from moving on this side, which forces the extension out here. Is that a more helpful way of saying it?
It's exactly as if the
So
belt
when
was
one's going
clamped
one
on the
way
end
and
of
one's
the
going
slide.
the other way,
Yes.
then we're in a tract or
Yeah,
Yes.
exactly.
extend. And when you're both going the same way, that forces the thing to spin.
Correct.
Exactly.
I'm beginning to understand now, finally, Sophie, I'm slow, okay? So when I'm spinning the belt, the arm could push in and out, is that correct?
Yes.
Okay.
But you can control that potentially. We've yet to try it with programming encoders.
Or locks along the
Because,
sides.
because the distance that the arm is extended or retracted is proportional to the difference in the encoders of the two motors.
Got it, you're encoded.
So if they're synchronized, right, to be at a set difference apart, then you know exactly how far the slide is.
Mhm.
If the slide comes back or goes out,
And you
then
can
that
still
difference
use
changes.
encoders to say, I wanna go out only 18 inches
Correct.
as well by counting encoder ports. Cool.
Yes.
Okay, so, like, two questions about the robot, slide.
Okay.
Is that, so one, how did you, I kinda saw it in the robot reveal video, but I was like still kinda confused about it. How did you increase the traction on like a relatively small magnet base? And two, you said that you made the base pretty heavy. How did you go about doing that? Especially because I feel like there's a lot of plastic extrusions that make up the base, so.
There's a
So-
platform if you want.
Oh, if I'm getting it, you're asking about butterfly. How'd we do it and how we make it heavy? So to show our butterfly mechanism, this robot,
You wanna lock them, or?
you unlock it with your hand. That's fine. So these mechanisms, I don't know if you can see them from over here. You can come over here if you want to get a better view of it. But so we had at the start of the season just normal mechanism drivetrain. And then we decided we needed pushing power, so we decided on implementing these. So they're just, we have an extra wheel module, butterfly module, wheel module, for each side of our drivetrain, for each wheel. And they're like pushed out by this servo using an over the center linkage so the servo doesn't hold the strain.
The over the center linkage locks it in place, which is why it's so difficult to turn it by hand.
Yeah,
Well, this one.
you didn't fully extend it. But you were also asking about weight.
One of the big things that added to our weight are these steel plates. So we specifically added them because they're each like two and a half or 5
2.5
pounds.
pounds.
2.5 pounds, which weigh down the drivetrain, but we still have enough torque on our motors that it doesn't slow us down a lot.
Yeah, so we kept 4 of these and we said we are gonna put them on, run our autonomous and see at what point are we messing up our auton and our driving. And so that's why we have these on. And then also with the butterfly, having all of those modules and like just filling up all that space underneath our robot also added a ton of weight. Not a ton, but a significant amount.
Why don't you always run it with butterfly?
Because butterfly is a lot slower. So those wheels are slow, those wheels are smaller, and also the mechanism really came in handy for driving this year, especially on shared hub when you're not getting defensed against. If you're just a little bit away from the wall and you're like, that's a little like of a sketchy situation, you just strafe into the wall and you're good. And in autonomous, we were constantly strafing against the wall just a little bit to make sure we didn't hit those barriers.
So another disadvantage of our butterfly is you can't turn, right? You need to put the butterfly's mechanisms back up a little bit until the mechanism wheels touch the ground to turn, and then you would put it back up.
Yeah, we actually had it programmed in that whenever the driver would try to turn or strafe while butterfly is on, it would disengage just a little bit so the mechanisms could touch the floor. Yeah.
Wait, so like what is the traction material on their butterfly drives?
It's grip tape off of Amazon.
Okay, so like I'm looking at them, they seem like the surface area, like the contact between them and the ground isn't that big because like the wheels themselves are pretty small. So like I'm wondering like how are you getting such effective grip?
So it's obviously also the material of what it is, but also we're pushing them into the ground, so they are getting a little bit with the foam tiles, getting a little bit more of not just a flat like tangent line on the circle, but also a little bit of the sides of the grip. But the grip tape is really what did it. We tried out a ton of different materials.
And
Also, if you think about it, right, you have a certain amount of weight pressing down. Do you get more pressure downward if you have a large area or a small one?
Well, I mean, like, I think it's total, like, I don't know, there's some equations for, like,
Right,
how much.
but generally, if you have something with a small area, it's more force downward at those points. And so you actually get more traction if you're going over a smaller area than
So-
if you have a wide area.
And what happened was we used to have the wheels be like this big.
Yeah.
And what would happen is they would tear up the tiles.
They literally dug into the tiles.
We have some bad tiles now.
Yeah.
Okay.
So the
Because-
so the length of your things is really a function of how long do we have to make them until they don't tear up the tiles?
Yes.
In some ways, yes.
Because that's against the rules.
Yes.
Yeah. Or at least to the point.
And find a material that wouldn't tear up the tiles. I mean, so typically when people think traction, they think tanks.
Yeah.
Right? Tanks have wide surface area, but tanks work not because they have good traction, but because they're essentially floating on top. Like that, they go really well on sand because they're floating on top of the sand, not because they're digging into the sand. Right? And that's what enables them to move, but they can get pushed around. So it's really a smaller surface area. The other thing is the diameter of the wheel is less, so you get more torque, by definition.
Because for one rotation, you don't go as far, so you have less speed, which increases your torque.
Yeah,
Because
that
they're-
makes sense.
How often do you have to change the grip tape?
So we try to change it, we check it after every time we use it, and at Worlds when we were really using it, we changed it after each match for insurance. I'm sure it could have held up at least 2 or 3 extra matches, but why not? Why risk that?
How often did we change it at MTI?
MTI?
I don't think we changed it.
I don't think there wasn't a lot of defense at MTI except semis.
In semis?
We didn't change it after semis. Actually, we didn't change it in MTI.
I mean, is the grip tape like priced like platinum, or is it, a fairly reasonable thing off of Amazon?
I think it's fairly
Reasonable.
reasonable.
Okay.
It's reasonable.
So you could replace it every single match and you'd be, for the whole
That
year.
gets,
and
that
you'd be
gets a
under
little
$50.
less reasonable, but you get a roll of about, 5 feet? Is it 5 or 10 feet?
It's
Probably 10.
So
fine.
you get a roll of 10 feet, it's like gaff tape, same price as gaff tape.
Yes.
So you said that like your Auton was kind of Magnum dependent. So built into the hardware of your robot, did you have like distance sensors or something, or was that mainly like a Roadrunner like software thing?
So we just use encoders and we have IR sensors, which sense the white line.
Right here.
So basically we just had a sensor that could see the white line and we just reset every time we left the warehouse. And that's why we were consistent on placing. Yeah.
On the differential slide, what's the end ratio for the intake?
The end ratio for the intake.
3.7. It's like,
I have no idea.
okay, it's like
It's
5
gonna be
to 1.
it's gonna be about 6 to 1.
That sounds right.
Yeah.
Because it's gonna be 3.7
And then the 42.
times 4 divided by 6. Or,
Okay.
no, sorry, the other way around, times 6 divided by 4.
Okay.
So, yes.
Yes.
With that slide, when it kind of slide out really long, how to make it more stable and kind of steady?
So are you talking about like the stability and like
Yeah.
the twist that this has?
Yeah, sometimes kind of shake,
Yeah. So the reason that this one specifically is really shaky or loose, you could say, is these slides I think are about 4 years old,
Yeah.
and especially with the 3-stage slides, because of the 3-stage slides get a lot of slack in them over time, and we've used these for multiple prototypes. So I think that's a main cause for the flex in it. But also with the weight on the end, you're gonna get a little bit of flex. But that's the point of a differential.
But one of the good things about this is because you have 2 belts balancing it on both sides, if you turn it one way, the other belt will get increasingly tensioned and it'll pull back. So
And-
it'll shake less.
Yeah, to that point, on this robot, we had one side belted, and we did notice that some of our belts, we replaced these slides once because this belt had too much tension and was pulling in on our slides, causing it to flex this way, which was bad for it. So this is a lot better for that purpose. Yeah, what's up?
So if you're running the intake while your slides are extended, you're susceptible to other teams, I guess, pushing back on the slides, correct?
Yeah, with any elevator, anyone can push on your slides. Yeah. Awesome. Any other questions?
Let me look for our next speaker.
Well, while you're looking, we'll answer more questions.
Yeah.
It goes with me. Because I'm taking it to our next event later. Alrighty. Yeah, I know. I'll see y'all whenever I see you.
But the percentage told you that you're trying to use like control. You gotta act like they're official stories, okay? You're the virtual. I don't care if you just depressed. I have to find out these. Maybe it'll become true eventually. Whatever. They laugh. It's the girl. It's the girl actually is so I got to say, it's a story. It's a story. That's what it's going to do. Wait, how much is because like she would be the one who would know herself, right? Tell me.